this is for year 11 methods. We're looking at question 3 from exercise 13H. Now we've got a scenario, we've got a carbon molecule and it's radioactive. So it has a half-life of 5730 years. It means that, what that means is that after 5730 years, the quantity we have is half of our initial quantity. So it just decays to half after that many years. So it's used to determine the age of ancient objects. A Babylonian cloth sample has now 40% of carbon-14 that originally has. How old is the fragment of cloth? So first of all, let's get our model going. So we can use n equals AB to the t. Now I know that initially, well, not initially, I know that after t equals 5730 years, that I have half, so I know my n would be half of my initial weight. Half my initial weight. Because after that many years, it's reduced to half. Okay? Now, I know my initial weight in the exponential equation, in the model, is our a value, so it's half of a. Now, this is quite useful. Why? Because I can actually sub this in. And it looked kind of weird how we subbing in, you know, something that we don't know, but it doesn't matter, we can still sub it in. So when t equals 5730, n equals half of the initial amount. And we don't know what the initial amount is, but we don't need to. So when I sub it in, so instead of n, we have half of a. We've got a, b to the t, 5730. Now what we notice here, we've got a's on both sides. I can cancel them. I can divide both sides by a. When I do that, it gets rid of it, because it's a divided by a is just 1. Now I can work out my b value from here, because I've only got one variable and one unknown. So I use my cas, 0.5, half is equals 0.5, x to the power 5730. All I'm doing is solving for this. So advanced solve, and I get my b value to be 0.999879, 0.999879. Okay, so b equals 0.999879. Now I've got my b value. I don't know my a value, but that doesn't matter, because I want to find what happens, how old is the fragment sample when it's 40% of its carbon-14. So 40% of carbon-14 means 40% of its initial value. So 40% of A, that means that we want to find the time when n equals 0.04a, because it's 40% of the initial value, its initial value. So since we know our b value, we know that the equation is now n equals a, b, which is 0.999879, to the t. Now n is 0.04a, because we need to find out when it's 40% of the initial value. And all we're doing is solving for t, because what happens again, the a's cancel out, and we've got 0.4 equals 0.999879 t. And we're trying to solve for t because we want to find out how long it takes for the carbon to reach 40% of its original mass. So all we do is use our cas again. I just want 0.4 to equal Now, I'll use this value because it's more exact, and then we have it on a calculator. I'm trying to find when it equals, okay, I've got something wrong here because I didn't put a point. Okay, so we got our value of 7,575. So rounded, t equals 7,575 years. So in this time, well, it took that long for the cloth to have only 40% of its carbon 14 left, and that's how you do this type of problem.